Students, in this session we are going to learn a special type of isomerism, that is a tautomerism. Tautomerism, especially in a C double bond O compounds, that means carbonyl compounds. It is a special type of isomerism. Special type of isomerism. Special type of isomerism, especially in carbonyl compounds, CH3, C double bond O H, reversible with the CH2 double bond OH and H. So in these two forms we can see that C double bond O, carbonyl oxygen and carbon, here carbonyl oxygen and both carbon, here oxygen with a OH hydrogen, then here carbon same as sp2 carbon, but a carbon double bond with another carbon, here carbon double bond with the oxygen. So in this isomerism, here double bond pi bond, in double bond contains a pi bond shifting on oxygen, then from CH3 one hydrogen abstracted by oxygen, then carbon and hydrogen bond shift as pi bond. Again it is reversible, like from here hydrogen, this hydrogen and oxygen bond will shift between carbon and oxygen, then carbon carbon pi bond will shift between hydrogen and carbon. So this is keto form, this is enol form. We know CH3CHO is acetaldehyde. CH3CHO is acetaldehyde, enol form. In this isomerism having a condition, if we know this isomerism condition, then easy to identify tautomers. Which of the following compounds will exhibit keto enol tautomerism, that type of questions in a NEET and the mains we can easy to solve. Alpha sp3 carbon, which has a hydrogen between both carbon and hydrogen sigma bond, delocalized with the EWG, electron withdrawing group like C double bond O, NO2, CN, etc. So these groups are what? Keto groups, special type of isomerism, carbon containing a double bond O. then some of the compounds of nitro and some of the compounds of cyanides also will exhibit. So these groups all are electron withdrawing groups. So these electron withdrawing groups attached to what? sp3 carbon, which is having hydrogens, alpha hydrogens, alpha sp3 ch sigma bond, ch sigma bond, ch sigma bond delocalized with the electron withdrawing groups like a C double bond O, NO2, CN, etc. Okay, this is the main condition. If we take a acetone, if we take acetone is alpha sp3. If we see acetone also having a carbonyl group CH3 C double bond O CH3. Now here 6 alpha hydrogens are there. 6 alpha hydrogens are there. This is reversible with the CH2 double bond COH and CH3. So one hydrogen from any one of CH3, okay, that is shifted to oxygen atom. So it is nothing but a proton shifting isomerism also. Okay, so H plus ion shifting to what? OH oxygen place. So O minus is subtracted by H plus ion. Okay, so proton transfer like that also we can. Okay, so carbon oxygen double bond will become a carbon double bond CH2 double bond C, then OH. So it is keto form. This is enol form. Keto form and enol form. This is one example. In some cases, keto form is more stable than enolic form due to strong CO sigma R pi bond than CC sigma R pi bond. Okay, that cases we can see. So in this isomerism we have to understand which hydrogen is shifting. Alpha sp3 carbon CH sigma bond. Okay, so delocalizing in this isomerism. So alpha sp3 carbon hydrogens are shifting to what? Oxygen place. Okay, see then in this isomerism, keto form, some of the compounds keto form is more stable than enolic. Keto form is more stable than enolic form due to strong CO 82 kilojoules, strong CO bond. So what type of CO bond it is? Either sigma or pi, anything, sigma or pi bond, then CC sigma and pi bond. See, not R here, and okay, sigma and pi bond is CO sigma and pi bond is more stronger. Okay, stronger than CC sigma or pi bond. So which has the energy, bond energy like 60 kilojoules. Here 82 kilojoules. So what that compound example, one example I will write like CH3, C double bond O, CH2, C double bond O, CH3. Very important, this isomerism. NCERT books also they have not given, but many questions they are asking from keto enol tautomerism. Okay, so this is like a ester group. We can take OCH3 reversible with the CH3 COH. This is alpha carbon. So hence 5 hydrogens are alpha hydrogens. So from here one hydrogen is shifting, double bond CH, single bond, double bond O CH3. Okay, either these hydrogen will shift, but this oxygen will not involve now, because here C double bond O CH3 is there. So one side alpha hydrogens are this, but this carbon having a 5 alpha hydrogens. This carbon having how many alpha hydrogens? 2 alpha hydrogens. As our condition, CO is a sigma and pi bond 82 kilojoules. So more strong than CC sigma and pi bond. Fine. See then. So this keto form is 95% stable. Enol form is 5% stable. Okay, so this is one example. Another example also we can see. This is one example. Another example also we can see. CH3 C double bond O CH2, C double bond O C2H5. Okay, this is ester group. See then, here also same thing. CH3 C double bond O CH, C double bond O, no, single bond O H, then double bond C double bond O C, C2H5, C2H5. Okay, so same thing here also. This carbon having a 5 alpha hydrogens, any one of alpha hydrogen will shift. So in this type of compounds, keto form is a more stable. Keto form is more stable. So keto form 92% keto, then 8% is enol form. Okay, so here condition we have to understand CO bond energy is more than CC bond energy, sigma or pi bond, any bond. Okay, see then, some compounds enolic form is more stable than that of keto form. See, once you check these notes completely, after that you can write. Okay, okay, we'll go to next. See, now keto form is more stable, we have seen. Some of the compounds enolic form is more stable, that also we will see. Enolic form is more stable in some of the compounds. That type of compounds also we can see now. In some compounds, in some compounds, enolic form is more stable than keto form due to intramolecular hydrogen bond aromatization and conjugation. So in these three cases, enolic form is a more stable. In these three cases, enolic form is more stable. So first case we can see. Which is the first case? Intramolecular hydrogen bond. Intramolecular hydrogen bond. Intramolecular hydrogen bond. Intramolecular hydrogen bond means in the first video I have explained. Within the molecule, hydrogen and high electronegative atom forming a bond. The type of bonds are intramolecular hydrogen bonds. Fine. See now. Intramolecular hydrogen bond CH3 C double bond O CH2 C double bond O CH3 CH3. Now intramolecular hydrogen bond in a keto form. See, intramolecular hydrogen bond representation from keto form to enolic form we have to write. Okay, keto form to enolic form we have to write. Then there is what? Hydrogen bond representation we have to show. How it will form a hydrogen bond. See, from here hydrogen is shifting. Hydrogen, then CC double bond, CH, C, CH3, then double bond O. So between these two, hydrogen bond is forming. So in this case, enol form is a 89%, keto form is a 11%. Okay, so keto form is more stable due to strong CO and CC. What? CO bond is more stable than CC. CC sigma r pi. Then enolic form is more stable than keto form due to what? Intramolecular hydrogen bond aromatization. These are fine. So now we'll go to aromatization. Aromatization will go. See, clearly if you write your notebook, then easy to understand. My videos will be in channel only. No need to worry about it. You can write as your convenient time. Okay, if you have anything, any doubts are, you can comment in a chat box. Okay, see second one. Aromatization. Aromatization means what? Forming a conjugated system. Okay, aromatization. What? Aromatic ring formation. Conjugated system means alternative pi bonds are there. That is next condition. So aromatization means forming a aromatic ring. See, keto form, is a stable with the enol form. See, here 1 2 3 3 pi bonds are there. See here, from here one hydrogen shifting to oxygen place. Okay, then this bond shifts as a pi bond. So this is a keto form, this is keto form, this is enol form. So what is the percentage, these percentages and all, how to calculate? These are, see, conditions we have to remember. This and all you don't worry. See, according to aromatization, which of the following compound is a more stable? Enolic form is a more stable than keto form. Okay, see, according to bond energy, which of the following is a more stable? So keto form is a more stable. This is aromatization. Third one is a conjugation. Third one is conjugation. See, double bond O, double bond O. Double bond O, OH, double bond. See here, two ketonic groups, from here one hydrogen. See, this pi bond will shift to an oxygen, from here one hydrogen will shift to oxygen, then the sigma bond will shift as pi bond. See, now alternated double bonds came. So the type of compounds are conjugated compounds now. So conjugation is formed in these compounds. 12% is a keto form stability, then 88% is a enol form stability. Keto form and enol form. Fine. So this is about a keto enol tautomerism. See, from starting onwards you can see video. Okay, special type of isomerism, acetaldehyde I have explained, then acetone I have explained, then keto form is more stable due to due to strong bond, CO bond, then enolic form is more stable due to intramolecular hydrogen bonding, aromatization and conjugation. Now nitroenolic form, nitroenolic form we will see once. Okay, nitroenolic form we will see. Nitroenolic form we will see once. Nitroenolic form is a nitroenolic form. Nitroenolic form. RCH2 single bond N double bond O, then single bond O, then RCH double bond N OH, then in a nitro group having a one double bond O, another is a dative bond. Already we know in chemical bonding itself. See, CH2, two alpha hydrogens are there. From here, one alpha hydrogen shifting to oxygen place. Okay, towards oxygen. Then it is a nitro form. This is enol form. Nitroenolic form. In starting one another group also, electron withdrawing group, another also I have given, that is a HCN. Sorry, cyanide I have given. That also I will give. See, very important. HCN and HNC. These both are tautomers. HCN and HNC both are tautomers. Very important it is. See, here hydrogen single bond, triple bond, nitrogen. Then hydrogen will shift to nitrogen. See, hydrogen ion shift only na, proton transfer only na. tautomerism means. See, HNC, HCN, HNC. See, hydrogen see, then positive charge, then negative charge. HCN and HNC both are tautomers. So this is a nitroenolic form and with cyanide. Okay, now we will see some questions about it. Some questions we will see that are previous NEET questions. Just compounds they are giving, which one will exhibit a keto form, keto enol tautomerism. Okay, which of the following will exhibit a keto enol tautomerism, like that questions they are asking. Okay, clear students up to here? See now another question. Now see, by seeing now itself we can see, we can tell what by seeing question itself we can tell answers. Like that type of questions these are. Which of the following question, which of the following, which of the following compounds, which of the following compounds will exhibit keto enol tautomerism? Okay, see, previously you have seen all compounds, nitroform and cyanides also you have seen. Hydrogen cyanide and hydrogen isocyanide both are tautomers, not functional isomers. Okay, remember. This is question. See now, C6H5C double bond OH, another C6H5C double bond O C6H5, C6H5C double bond O CH3. Okay, fine. Then C6H5C double bond O CH3, CCH3, CCH3, CCH3 thrice. Okay, another compound you see, CH3 C double bond O CH2 CH3. Then C double bond O then another benzene, sorry, say a 6-membered ring with the 2 places double bond O. 6-membered ring with the 2 places double bond O. 6-membered ring bicyclo compound, 1 place double bond O. 6-membered ring, 1 place double bond O, another place is CH3, another place is CH3. This also bicyclo compound. Okay, another is a C6H5, here double bond O inside, unbridged carbon, little bigger, I'll write here double bond O. Okay, so now which of the following compounds will exhibit a keto enol tautomerism? That is, see, this is a functional group carbonyl carbon, here no alpha hydrogens, it is a benzene ring. So here no alpha hydrogens, it will not exhibit. Okay, see, both the sides of benzene rings are there, so ketone it is, so it will not exhibit. Here one side no alpha hydrogens, another side 3 alpha hydrogens are there, so at least 1 alpha hydrogen is enough to give the tautomer. Okay, see then, in this compound no alpha hydrogens. Okay, see, this is a benzene ring, so no alpha hydrogens. Here alpha carbon is there, but that 3 hydrogen places methyl groups are substituted, so no alpha hydrogens, it will not exhibit. Okay, see, this is here 3 alpha hydrogens are there, here for 2 alpha hydrogens are there, total 5, it will exhibit. See, this is here, see, alpha hydrogens in this, see, here this carbon 1 2 3, then alpha is there, so sp2 carbon, but our condition is sp3ch, fine, so it will not exhibit. In this, see, here bridged hydrogens are there, here 1 alpha carbon is there. Bridged hydrogens will not involve in a keto-enol tautomerism. Okay, so normal hydrogens only will involve, so that this is will exhibit. Okay, then this is here 1 alpha. In this again, see, these 2 keto forms are there, here this is alpha, so it will exhibit. Then here 2 keto forms are there, so this is alpha, for this carbon, for this sp2 carbon 2 alpha hydrogens are there, for this sp2 carbon 2 alpha hydrogens are there, it will exhibit. See, here alpha carbon is there, here alpha carbon is, 1 alpha carbon is a bridged carbon, another alpha carbon is a methyl group carbon, so it will not exhibit. Okay, see then, this is unbridged CO is there, here alpha, this is alpha, but here condition we have to write bridged hydrogens. Bridged hydrogens do not involved in tautomerism. Bridged hydrogens do not involve in tautomerism. See, like here one side hydrogen, bridged hydrogen, another side hydrogen is a bridged hydrogen. Okay, so this is about keto-enol tautomerism. See, if you have anything still more, you can comment on comment box, chat box, so I will make another video and I will explain. Okay, so conditions alone, if we have to remember, then NEET mains exam, this and all simple. See, NCERT books, they have not given tautomerism. Okay, so check properly. Thank you.